Okay, so let's go over some homework problem from 3.6 about Taylor polynomials with the error. So some of the problems here, like 127, 133, and 135 in the syllabus, I don't want you to do them. They are more complicated than what we ever need to do. But this is something that you might want to, we need to calculate. So we're gonna have to calculate the approximate value of this guy using n is 4. That means we're gonna use the Taylor polynomial 4. And we also want the error, or at least an estimate of the error. Now, this one, remember, the value that we have to calculate, that is going to be our b. So we know what b is. They have given us a, but we could have perhaps chosen it too, like that. That's an easy value for a, which is close by pi over 5, or 5 is a little bit less than 0.6. A little bit more than 0.6. And then finally, our function f of x is cosine of x. So we make our table, and we have to go for 1, 2, 3, 4. Later on we will need the fifth derivative, but you'll see the derivatives are very easy. So we start with cosine of x, and then remember what we do is we always go take derivatives. So take cosine is minus sine of x, don't forget the minus sign. Take the derivative again, that gives me minus cosine of x, and keep going this way. The derivative of that is minus minus sine, which is positive sine of x, and the derivative again is cosine of x. The next column is the column we use now this function, and here we plug in a, which is 0, so 0 goes in there. And that's very easy, cosine of 0 is 1, and sine of 0 is 0. So then here, of course, we have a minus 1, this is a 0 again, and then this gives a 1. All right. Then as the last column, these are going to be the actual coefficients that we need. We're going to have to divide by n factorial. The first two, that is never anything, n 0 factorial 1 factorial 1. The first one that we have to deal with is this one, that is minus 1 divided by 2 factorial, which is 2. 0, of course, stays 0 no matter what we divide it by, and then finally we have 1 over 4 factorial, which is 24. So 4 factorial is 24. Okay, so this now we have T4. T4, we know that these are the coefficients of the powers of x minus a. Now a is 0, that means we have really powers of x only, and the only coefficients that we have are the degree 1, degree 3, and degree 5. So let's write it up. Sorry, degree 0 here, sorry, I misspoke. Sorry. Degree 0, degree 2, and degree 4. These are the degrees here. So we have the constant term for degree 0, then degree 2, this is this term, is minus a half x squared, that's the degree, and then degree 4, because the other two are 0, so we don't have them, we have plus 1 over 24 x to the 4th. So this is our Taylor polynomial, and now we know by the theory of Taylor polynomials that the cosine of pi over 5 is approximately the same as the value of this polynomial in pi over 5, which is this is equal to 1 minus a half pi over 5 squared plus 1 over 24 pi over 5 to the 4th. And you can leave it like this, but of course you could calculate this with a calculator if you really want to see what's going on. Okay, but what is more important is what is the error here? And the formula for that is, we know that the error is at most, we take the maximum of the derivative. Now, which derivative? Well, we have to go to the next step here, the fifth derivative, which of the derivative of cosine is minus sine x. We have to take this, so this is the fifth derivative we're going to take of x, but we always take maximal values, so this minus actually will not play a role. And this is for x's between a and b. Now, a is 0 and b is pi over 5. It's in this order. We always have to make sure that we write it in the right order. That's the one thing. There are two more parts here. There is the b minus a to the power 5, the same power here. This is always talking about n plus 1 over 5 factorial, which is 120. Okay, so in our case, what are we going to do now? So we know that the derivative of cosine x, the fifth derivative here, is minus sine x. But we don't want to think too much about it because it's actually always rather small. We use that the sine of x, and the same for cosine, is at most 1. And for us, 1 is really not big. It doesn't make this really big. especially because this number is normally very small. This number is small, so whatever this number is, as long as it's not too big, it's fine. So we're going to replace this by 1. So this is less than 1. That is this number here. Now what is these things? B is pi over 5 minus a, which is 0, to the power 5 divided by 120. And pi over 5 is 0.6. 0.6 to the power 5 is already 0.00 something, so 100, and then this is almost 1000 or something like that. So what we have found now is that the cosine of pi over 5 is equal to this number, give or take this number. And that's enough for answering this problem. And if you answer the problem like this, that's full credits.